In this video, we're going to talk about how inverse functions are represented in a table, a graph, and an equation. So a function in function notation would be x, f of x. The inverse of that function would still have an input, we'd call it x, but we would use the notation f to the negative 1, x. This negative 1 looks like an exponent, but it doesn't have any operation. It's just an indicator that this is the inverse of the function f of x. In a table, you'll notice that the columns are switched. So in the original function, you input negative 3 to get out negative 5. In the inverse function, you input negative 5 to get out negative 3. That's the same for all of the inputs and outputs of the function. It doesn't matter that the rows have changed order, just that the numbers in the input in the x column now become the numbers in the output column. What happens in a graph is that the coordinates change. So this point here, 4, 9, becomes this point here, 9, 4. So you've switched, just like you did switching input and output, x and y in the table, you've switched x and y on the graph. What that winds up doing is causing you to have all these points mirrored over this diagonal line, which I didn't draw very diagonally, but the diagonal line that kind of cuts the graph in half down the center, y equals x. So that diagonal line, I'll draw it one more time, much better. You can see that these points are reflected over this line. So in a graph, there is a reflection, and the reflection, usually you're used to it being like the x-axis or the y-axis. The reflection here is over the line y equals x. Finally, in the equation, you can see the notation here again. Here is f of x. Here we have the notation that this function here that we've written is the inverse function of the function f. And again, that little negative 1 is not a mathematical operation. It just indicates that it's the inverse of the function f of x. The function f of x here is the function where x is multiplied by 2. 2x happens first, and then you add 1 to the solution. The inverse function is the inverse operations in the opposite order. So first you're going to subtract 1, then you have to take that whole result, which is why I put it in parentheses, and divide it by 2. So again, it's the inverse operations in the reverse order. You have to make sure you do both of those things to make an inverse function. Finally, you can check if your inverse function is indeed an inverse function by taking any number, f of 7, plugging it into the original function. So that would be 2 times 7, 14, plus 1 is 15. And then taking that answer and plugging it into the inverse function. So we take the inverse function and we do 15 minus 1 divided by 2. 14 over 2 is 7. Since our original input and our final output are the same, we've checked and we know that this is indeed the inverse of this original function.